Hello and welcome to EE233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at our sort version 3, and this is part of a larger series of videos that are looking at different sorting algorithms as well as comparing their efficiencies and looking at a couple of applications of one of them. So in this particular video, what we're going to do is another sort in which we swap two values when we find that they need to be moved to another location. However, unlike sort version 2, we are not simply going to swap neighboring values. We are going to compare a value globally. In other words, we're going to take the first value and we're simply going to compare it until we find another value that is lower. Once we find another value that is lower, we're going to continue to look and compare that value to the rest of the values in the array. And once we have found a globally min, or the smallest value in the array or in the file, once again, we're assuming that we are doing ascending. Once we found the smallest value in that array, we are then going to swap the location of that smallest value and put it in the lowest indexed location. And so essentially what we're going to do is we're going to do a modification of the swap that we saw earlier. The value at that location, at that second location, in other words, what was there before we put the lowest value, is then going to be moved to the location where the lowest value was found. So, for instance, if you take a look at our file, and let's assume then that the lowest value, if you looked at all of the values in the file, you could scroll down through it and you would discover that the smallest value is 60. What we would do is we would take this value, we would copy it into a temporary variable, and then we would go to the first location, in this case, the top of the file, and the value is 93, and we would simply copy 93 down to the 99th row, and then we would copy 60 into the first row. And so essentially what we're doing is a slightly modified version of the sort v2. So let's go ahead and get started. We'll take a look at our code. Once again, we are simply using a while loop to open up the, to read the contents of the file until we either hit end of file or we reach 100 values. This, once again, does not do any error checking. It doesn't check to see if the file is actually a valid file. We're going to assume for this particular example that you have put your sample01.txt in the correct location. Once it gets done reading either to the end of file or 100 values, it simply closes the file. We are then going to put our code roughly around line 328. But before we get to that, let's take a look at what the remainder of the file does is, the remainder of our function is that it simply writes the sorted values out to a specified output file. And then it closes the output file. Also note that we have a printf statement down here indicating a loop counter. We'll come back to this in a later video, but essentially what we're going to do is we're going to compare the efficiency of several of these algorithms. Now, before we get into code, I want to take a look at our temporary variables for just a second, or our variables that we're going to be using, particularly now the data types notice that the data types of our unsorted chunks and specifically our found value are the same. So it's important that if you're going to store the found value, that you make sure that the data type of the found value matches the data type of the array. In this case, it's going to be integers. You'll notice here that in our fscanf, we use %d. That would also change depending on the data type. Now, what we want to do now is we want to start off by addressing the order, okay? And so in this case, we've got ascending or descending. To begin with, we're going to assume for this example that we're only going to be dealing with ascending, and then we're going to come back in and then deal with descending. But to begin with, I'm going to take a slightly different approach than I did in the earlier videos, in that I'm simply going to go ahead and set up my if structure. And we'll start off with order equal to ascending, else if order equal to descending. And although these are the only two enum options, we still want to have an else. And in that else, we simply want to print f error unhandled enum. Now, truthfully, we should never reach this. As a matter of fact, we're going to have a couple of issues here, in that we would ultimately end up printing a file, an output file, that essentially would have no differences between the input file. In other words, we're simply then going to be moving the unsorted chunks into the sorted chunks and then writing it to a file. So you would have other problems that you would need to handle, or you would need to restructure your logic. But it's a good practice to simply handle all of your enums, and then under the else, simply put a print statement or some other information back to the user that indicates that something went wrong. Now, the next thing that we want to do is as we specified earlier, we want to loop through the array, or loop through the contents of the file. I'm going to use, whether it helps you to think of this in a file format or in an array, doesn't really matter. But basically in memory, you've got these values right here. And so what you want to do is you want to loop through each one of the elements in the array, essentially looking for the lowest value. And if you find the lowest value, then you want to change the location of the lowest value to wherever you started your search. So in other words, ideally, the first pass would result in the lowest value being moved to the 0th index. Well, what do you do if you are sorting the data in ascending order and the lowest value is already in the correct spot? So in other words, if the lowest value resides at index equals to 0, is there any need to move anything? Well, the answer is no. And as a result, you see here that I have 3 temporary variables. The found essentially acts as a flag to tell me whether or not I have to move anything. The found index tells me the location of the item I need to move, and the found value is technically a little bit redundant. It's a convenience variable, and you'll see why in a little bit. But essentially what that does is that allows for me to store the value, or the lowest value, if I'm looking at ascending order. It allows for me to store the found value as opposed to having to deal solely with the index. And once again, you'll see in just a minute why that's somewhat of a convenience variable. The second question that you want to ask yourself is, how many times do I need to look through my array? And so if you look at this particular example, and the reason that I essentially limited us to 100 rows is so that we can sort of think of this in that if you have 100 rows of data, how many times do you have to search for the lowest value? Well, the answer is that you actually only have to search rather, one less times than the number of data. So in this case, the number of rows of data is 100. So we only have to perform 99 passes. And so to set this up, what we want to do is we'll initialize a couple of our variables here. We'll start off with our found variable. We'll say found is equal to false. For this particular example, we can either use a for loop or a while loop. It just matters based on whether we want to initialize our indexes inside of the for loop construct or use a while loop and initialize it outside. Doesn't really matter. So in this particular case, what I want to do is I want to say for our found or low index rather. So for our low index equal to 0, low index less than our count minus 1, and then low index plus plus. And so that allows for us then to loop through starting at the lowest index or the 0th element in the array and compare then that value to all of the other values. So let's continue with our initialization here. We can also initialize our found index equal to 0, which then brings us to what we would initialize our found value to. So we could say found value then is simply equal to the value in our unsorted chunks, square brackets, found index. Now, the question that we want to ask ourselves is, do we want to compare that value to itself? So in this case, what we've done here is we have simply specified the first value as being the lowest value. So to avoid comparing the found value to itself, at least with the first value, what we want to do then is we want to start off with our search index and have our search index simply equal to whatever the low index is plus 1. And so essentially what this is going to do is it's going to start off searching at the 0th element plus 1. So in other words, we're going to take that low index value and we're going to compare it to its neighbor, which is going to be at low index plus 1. We're going to continue then with our search index up to our count. And then likewise, we are simply going to increment our search index plus plus. Now, what we do at this point then is we simply do a comparison. Now, the initial value here, our found value, we could build it off of our found index, or what we can do is we can simply move this inside of our outer for loop. And instead of using the found index equal to 0, we can simply initialize the found index equal to the low index. And so essentially what that does is that assumes that the lowest value for any pass is the first value that you have left in the array to check. Put another way, when you first start looping through the array, you blindly assume then that 93 is your lowest value. You then compare it to 97. And if 97 is lower than 93, you keep 97. In this case, it's not. So what you would do is you would move on to the next value. In this case is 65 less than 93. The answer is yes. So you have found a new low value. So to put this in code, you would simply add an if statement in which you would compare the value in the unsorted chunks, square brackets, and what you would use is you would use the search index. So you would compare the unsorted chunks square brackets search index, and if that value is, if we're looking at ascending here, if that value is less than our current found value, so in this case found value, if that is less than our found value, this means we have found a new low value, globally low value. Else, we keep looking. And remember that in this case, the else is going to mean that it's either greater than or equal to. And if they are equal, there is no reason to move that value. So what does it mean if we have found a new low value? So the first thing that we want to do is we simply want to say found equal to true. The second thing we want to do is we want to say found underscore index is equal to whatever that search index is. And the third thing we want to do is we want to say found underscore value then is going to be equal to the unsorted chunks, square brackets, whatever that found index is. And hopefully at this point, you can sort of see why the found value is a convenience variable, because technically what we could have done is we could have compared the unsorted chunks square brackets search index to the unsorted chunks square brackets found index. At this point, in either scenario, we simply want to go ahead and increment our index. And so in this case, we have the search index keeps moving forward, and in the outer for loop, the low index keeps moving forward. So basically what happens is if we have 100 values in the file, the outer for loop is set to run 99 times starting at the first value, and the inner loop is going to run 99 times starting at the second value, continuing all the way through to the end. Now, if we've made it the whole way through our inner for loop, we simply need to check to see if found is equal to true, which means that effectively we have found a new, in this case, low value if you are looking at ascending. And so under the else, then it simply means to do nothing. Well, what does it mean to find a new low value? As we mentioned earlier in the video, we would like to swap where the value at the location of the found index with the value at the low index. So the first step would be to utilize that temporary variable and once again use our unsorted chunks array, and we want to take the value at the low index and we want to store it in our temporary variable. The second step would be to take the unsorted chunks, square brackets, low index, and assign to that location the value of the unsorted chunks, square brackets, found index. In other words, the index of the location of the lowest value is going to be used to ultimately retrieve the lowest value. Another way to do this would be to simply use the found underscore value variable. Once again, it's a convenience variable. It isn't technically needed. And then the third step would be to say unsorted chunks, square brackets, found index. In other words, wherever you found the lowest value, you now want to overwrite that with the value that you pulled out of the low index, or the value that is stored in that temporary variable. So if this seems a little confusing, I would like to just simply remind you that if you had two people sitting in two chairs and you ask them to switch chairs, but you required that someone was seated at all times, you had to provide them with a third chair. So essentially what they would do is they would slide from one chair over to that temporary chair, allowing the second person then to slide to the first person's chair. And that person that's sitting in the temporary chair could then slide to the second person's original chair. That's the reason for the temporary variable. Now, as I mentioned earlier, we kind of just waved our hands at the order enum. We'd like to come back to that. And so what we want to do now is we want to go ahead and handle the descending. So effectively, because of the way we've structured our code, we have some duplicate code. In other words, everything that is inside the true branch of the if statement now gets duplicated in the else if branch, with the exception, or rather with the only change being the sign. And so in this particular case, what I'm going to do is I'm going to change it from less than to greater than. And effectively what we have done is we have found a new high value. But essentially the algorithm at this point is pretty much unchanged. The low index does not refer to the lowest value, but rather the location in the array. It is the lowest index that we have searched, or rather where we have started searching from. All right, so hopefully we've got no significant typos. We're going to go ahead and build it. Let's see if we've got any compile errors. Nope, this looks good. Now let's move up to our main and let's see if we can get this particular example working. Now, if you've already watched the sort version 2 video, you know that what we can do is leverage our argument count and the first switch. So what we're going to do now is we're going to add an else if. Our argument count, in fact, stays the same. So our argc is going to be equal to 5. For a quick reminder of what those would be, the 0th argument would be the executable. The first argument would be the switch of the function we wish to test. In this case, we're going to call it sort underscore version 3. The argument argv square brackets 2 is going to be the name of the input file that we wish to parse. argv square brackets 3 is going to be the output file that we are ultimately going to rewrite our data in. And argv square brackets 4 is going to be a string that corresponds to either the ascending or descending enum. So for our argv square brackets 1, we simply want to use the string compare I function, and we want to check to see, does it match, or does the argv square brackets 1, does it match sort version 3? And if it does, then what we're going to do is rather blindly assume that the argv square brackets 2 is our input file name, our argv square brackets 3 is our output file name, and lastly, the order is in argv square brackets 4, albeit as a string. So we're going to once again do this quickly. It's going to be string copy, and we're going to put in our input underscore file name, whatever the contents is of argv square brackets 2. Likewise, we're going to use our string copy function, and we're going to put in our output file name variable, whatever the contents of argv square brackets 3 is. And lastly, what we're going to do is we're going to use string copy then to populate our order string with the contents of our argv square brackets 4. Now, we want to check what the value is in the order variable. And to do that, we use the string compare I to compare the order with the string ascending. And if that matches, in other words, if that is equal to 0, we simply want to call our sort function using the ascending enum. Else if string compare I, and in other words, we compare the order to the string descending, spelled correctly, of course. That's probably going to be your biggest challenge here. And if that is equal to 0, then what we want to do is call our sort function using the descending enum. And then lastly, if we hit the else, in other words, the user has provided some combination of switches that we didn't actually expect, or in this case, a enum that we didn't anticipate, you simply want to provide them some help. So for this example, we simply want to say results then is going to be equal to sort underscore v3, and we want to pass to it the input file name as well as the output file name, and we now want to enter in ascending, but this time without the quotes. That indicates that it is the enum value. Under the else if, we simply say results equal to sort underscore version 3. We want to specify the input file name as well as the output file name. And for the enum, we specify descending. All right, let's go ahead and build this. Let's see if we've got any typos. No, looks like it compiled just fine. What I want to do now is I want to go to my command window, And I'm going to go ahead and type in dir. I'm actually going to go ahead and just clear the screen and then type in dir. And you see there that I have my SortDemo and my sample01.txt. Let's go ahead and run the SortDemo with the sort v3 switch. We're going to specify the input file name as sample_01.txt. For the output file name, I'm going to use a fairly verbose file name. In this case, it's going to be sample_01_ascending.txt. And I want to specify for the order ascending. And I hit enter, and we simply come back with loop counter version 3. That at least indicates that that printf that was at the bottom of our sort version 3 seems to be running. And if we type in dir, you'll notice that we now have a sample_01_ascending.txt. You can take that file and you can drag it and drop it into NetBeans, and sure enough, we have a value of 60 at the top of our file and a value of 99 at the bottom. So looks promising so far. Let's try our hand at our descending. So in other words, I'm going to change my output file to reflect a different sort order, as well as changing the enum, or the string that is going to be parsed for the enum, to descending. And once again, not very confidence inspiring, but if you type in dir, you'll notice that I now have a sample_01_descending.txt. And sure enough, it starts at 99 and it continues down to 60. So it seems like we have this working correctly. So once again, hopefully you found this video useful. And this is part of a larger series in sorting functions. So at this point, what you want to do is you want to pick one of your sorting algorithms that perhaps you either understand best or is the most efficient, preferably both, and you want to utilize it in some of your other functions. In another video, we are going to take a look at which one of these sorting functions is the most efficient, as well as some applications of different sorting algorithms. So once again, hopefully you found this video useful. If you have any questions or comments, don't hesitate to email me, and thank you for watching.